Okay, let's go do rules for divisibility. In this section, we would do divisibility by osculation. This is video number 6, part 3 of 3. I split the video in 3 parts, and this is the third part. In osculation, it's an indirect method. We don't try to find a remainder here. We do not even try to subtract the multiples of the divisor from the dividend. In fact, we add multiples of the divisor to the dividend and divide by 10 by discarding the 0 on the right. I have subtracted multiples of the divisor from the intermediate osculation results, and that is within the spirit of Vedic math, because that is we are trying to simplify as much as possible. Okay, let's continue with next section here. Next section is divisibility by osculation. Okay, let's continue. Look at some first principles involved here. Let's continue here. First, adding or subtracting multiples of the divisor does not change divisibility. Let's continue here. Second, 2 and 5 are factors of 10. For divisors of the type 2 raised to the power I times 5 raised to the power j, the multiples of 2 and multiples of 5, we can add zeros. When add zeros to the right, we are multiplying by 10, and we can do that repeatedly if necessary, and can get a number to become divisible by such a divisor. Okay, let's show you an example here. Example 1. 1 is not divisible by 5, but I can multiply 1 by 10 by adding a 0 and make it 10. So 10 is. Okay, let's continue. Another example. 1 is not divisible by 20. 20 is 2 times 2 times 5, okay, but 100 is. So I can multiply 1 by 10 twice. I can add 2 zeros at the end, and then it becomes divisible by 20. Let's continue. Another example. 1 is not divisible by 16. 16 is 2 times 2 times 2 times 2, but 1000 is. So 1 is not divisible, but I can multiply 1 repeatedly if necessary by 10 to get a 1000. Okay, and that's adding 3 zeros at the right. But 1000 is divisible. So in these cases, when divisor was of this type here, multiples of 2's and multiples of 5's. Okay, number of 2's multiplied by number of 5's. If that's the type the divisor is, we can make that number divisible by such a divisor by adding zeros to the right, or by repeatedly multiplying that. Continue. When a divisor ends in 3, 7, and 9, we cannot make a dividend divisible by such a number by repeatedly multiplying by 10 by adding zeros at the right. Okay, let's show you an example. Okay, example 1. 13 is not divisible by 7, and neither is 130 or 1300. We cannot make it divisible by 7 by adding zeros to the right. Okay, let's continue. Example 11 is not divisible by 13, and we cannot make it divisible by 13 by adding zeros to the right. Continue. In such cases, we can replace is 130 divisible by 7 by is 13 divisible by 7. The two are equivalent. Let's continue here. We will be removing zeros on the right. That means we will be dividing by 10 by discarding zeros on the right in the process of determining divisibility. Let's look at what divisibility by osculation is. Let's continue here. We would be adding multiplier of a divisor to make the right position value 0. Okay, this multiplier has to work with any digit in the right place. Let's see what we are trying to do here. We need to compute a multiple of divisor times right place value plus right place value. Right place is a common factor in these two expressions here, on one to the left of plus sign and one to the right. Let's see what's happened. Okay, so right place time divisor multiple plus 1 has a 0 at the end, so must be multiple of 10. That means that this number divisor multiple plus 1 must be a multiple of 10 too. Okay, that means divisor multiple plus 1 must be multiple of 10. What does that mean? That means that divisor multiple must end in a 9. Okay, so we need to compute a divisor multiple of the divisor which ends in a 9. Let's do an example, okay, to go through the steps. Example we take is 132 divisible by 7. Let's continue here. First is we got to find a multiple of 7 which is ends in 9, and that multiple is 49, which is equal to 7 times 7, and 49 does end in 9. Let's continue here. Then what we do, we will compute a multiple to be added, which is 49 times 2, which is 98. Okay, we're going to add 98. Okay, okay. So when we add 198 to the 138 we had is 230. We have a 0 we were looking for. Okay, let's continue. Now we do have a desired 0 in the right place. Okay, observe, multiplication by 49 is hard, and it is Vedic math. We are in Vedic math where mantra is short and sweet, one line mental solution when possible. Otherwise, simplify as much. Continue here. It's 132 divisible by 7, same problem again. Now first we will replace 49 by 50 minus 1 by addition and by subtraction of 1. Okay. So we got 50 minus 1 times 2 plus 132. Okay. So let's see what's that. That's 50 times 2 plus 132 minus 2. Okay. Okay. All right. So 2 minus 2 is 0. Okay. It is 2 and minus 2 will become 0. Okay. So the 2 minus 2 is 0. Okay. This 100 here, when we add 100 to 132, the carry is 10. We add the carry of 10 to the next digit on left, 3. That becomes 13. So it's a 1 and 13 here. And a 2 and a minus 2 will become 0. So, okay, so we get it. Let's see what happened. And the rightmost digit is this 0 here, 2 minus 2. We will divide that by 10 by discarding this 0. We would not change the divisibility by 7. We're looking for divisibility by 7 and dividing a number by 10 by discarding zeros on the right does not change the divisibility. Okay, let's continue here. Here example, if 13 is not divisible by 7, neither is 130. And let's continue with the example. Let's reiterate stress. First, obtain a multiple of divisor ending in 9. That multiple is 49 for a divisor 7. Okay, let's continue here. Second, use 50 minus 1 for 49, which is by addition and subtraction. Okay, let's continue here. Third, ignore minus 1, this minus 1 here, which changes the right position to 0, and we ignore that position anyway. Okay, let's continue here. Fourth, bring the carry from 50 times the right position is carry value is 5 times unit place, right place, to column on the left. Okay, so we would have 5 times the right place value to the, we would add that to column on left. Okay, let's continue here. Fifth, add the carry to the digit on the left, column on left. Let's reiterate again. Is 132 divisible by 7? What did we do? First, let me restate 2 steps needed to accomplish what we just discussed. Okay. First, multiply right column digit by 5. Okay, that's 5 times 2 is 10. Okay, let's continue here. Add the product to the digit in the column on its left. Okay, so we multiply right column by 5 and add that to column on left. Let's continue here. Okay, where did 5 come from? We got the 5 from 49. Okay, and then we got a second one more than before of 49. Then we use a 5 as a proxy for multiplication. Do the division now. Is 132 divisible by 7? Let's do the osculation process again. Original number is 132. Okay, let's continue. Multiple of 7 to use is 49. 7 times 7 is 49. We use a multiple ends in 9. One more than before is 50. And proxy we will use is for 5. For multiplying by 50, we'll use a proxy of 5. Okay, let's continue here. So osculate stuff is 5 times right digit plus the left digit. 5 times 2 plus 3, which is 13. Okay, let's continue here. Okay, 13 is a little larger number and larger than 7. I'm going to subtract 7 from it and make it a 6. I'm going to reduce the 13 to 6 by taking a remainder of 13 divided by 7. Okay, or I'm going to subtract multiples of 7 from 13 and get a 6 here. Okay, let's continue here. So we got smaller number 6. Okay, osculate again. 6 times 5. That's the oscillation of 6 times 5 or 5 times 6 plus 1, 31. Okay, so let's get 31 here. Okay, let's continue. Now we get left with 31 here. 31 is not divisible by 7. Okay, and neither is 132. So 132 is not divisible by 7 here. Okay, same example. Did you see what we do accomplish by osculation? Let's continue here. First osculation was 5 times 2 plus 3 equal 13. Let's see what we did. It includes multiply of 49 times 2 equal 98. Then add that to units placed. So 98 plus 2 is 100 with 0 and a 10 as a carry. Okay. Then add that carry to the digit on left to get 3 plus 10, 13. And divide by 10. Discard the 0 here by discarding 0 on the rightmost column. Okay. So this is all we did using a osculation method like that. Let's do another example here. Example is 144579 divisible by 7. Let's continue here. Original number is 144579. Let's continue. We're going to find a multiple of 7 which ends in 9. That's a 49. Okay, 49 is 7 times 7 and it does end in 9. So one more than before of 49 is 50. We'll use 5 as a proxy. Continue here. First osculation is 9 times 5 plus 7 equal 52. Okay, 9 plus the proxy 5 times 5 plus the number on left. 9 times 5 plus 7 is 52. Let's continue here. Okay, now 52 is too large a number compared to 7. 7 is what we are trying to divide by. Okay, so subtract multiple of 7 from 52 to get a 3. 52 minus 49 is 3. 49 we subtracted is 7 times 7. Okay, so we would get a 3 here. Okay, let's continue here. So we end up with 3 here. Let's do the osculation again with this 3 on right and 5 on left, which is means let's continue what we do. 3 times the proxy, 3 times the proxy 5 here plus the digit on left. So that's 20. We reduce that to 6. 20 minus 14 is 6. 14 is 7 times 2. We reduce that by a multiple of 7. 7 is the divisor. Okay, let's continue here. So we get 6 here. Okay, now osculate that again. We have 6 on the right column and 4 on the left. 6 times the proxy 5 plus 4 is 34, and we do that again. Reduce that by 28 to get a 6. Okay, now we are gone so far. We got 2 6's here. Now we're going to osculate that again. 6 times 5 plus 4 is 34. 5 is a proxy. 6 times 5 plus 4 the digit on left, and we reduce that again to 6. Okay, so we got another 6 here. Continue here. So 6 times 5, 6 times the proxy plus 1 is 31. So we got 31 here. Okay, 31 is not divisible by 7. So this 31 and neither is 144579. Example here is 1433719959 divisible by 49. Hey, I got this example from a leaflet prepared by Vedic Math Academy. Let's continue here. So number is 1433719959. Let's continue here. Multiple to use is 49. 49 times 1 is 49. It ends in 9. Okay, and one more than that is 50, and proxy is 5. Let's continue. First osculation is 9 times 5 plus the next digit here 50, and we will reduce that to 1. 50 minus 49 equals 1. Okay, let's continue here. So we osculate these 2 digits and got a 1. Okay, let's continue now. Now we're going to osculate again. 1 times the proxy 5 plus the digit on left 14. So next is 14 now. Okay, let's continue here. Now we're going to osculate that again. 14 times 5 plus 9 is 79, and then we subtract 49 from here. We're trying to figure out if it's divisible by 49. So subtract 49 from here, we get 30. Let's continue here. Okay, now we're going to osculate this 30 and 1 here. Okay, 30 times 5 plus 1 on the left. Okay, which is 151, and We take away multiples of 49, we take away 3 uh, times 49, which is 147, and reduced to 4. Okay, so we'll use, instead of 151 we got from oscillation, we'll continue with the 4 here. Let's continue, do oscillation again. 4 times the proxy 5 plus the digit on left, 27. Okay, now we got 27 here. Let's continue here. Now osculate that again. 27 times the proxy 5 plus 3. Okay, 138. We'll reduce that. So we take out 98, which is a 2 times 49 from here, and we got 40. So we'll work with 40 to start next. Okay. Okay. Now we'll continue again. Is 1433719959 divisible by 49, and we have so far osculated up to here. Okay. Let's continue. So osculate again. 40 times 5, the proxy, plus 3 digit on left, 203. We take away 196 from there, reduce to 7. 196 is 49 times 4. Okay, let's continue. So we got 7 to work with. Osculate again. 7 times the proxy 5 plus 4. 7 times 5 plus 4 is 39. Okay, let's continue here with 39. Now osculate again. 39 plus 5 times 5 plus 1. 39 times proxy plus 1 on the left is 196. Okay, let's continue here. And 196 is 49 times 4 is divisible by 49. 196 is multiple of 49, and so is 1433719959. So we have just concluded that this large number 1433719959 is divisible by 49. Continue and stay with the same example again for a while. So far we have decided that this number 1433719959 divisible by 49. We went through the osculation steps, and last number we had is 196. Okay, let's continue here. If you could not determine that number 196 is divisible by 49, you can osculate that again. Let's see what I mean. Okay, that means I have 196 here. 6 times 5 plus the digit on left, 6 times 5 plus 9 is 39. Okay, let's continue. Osculate again. 39 times 5, 5 is the proxy, plus 1 on left is 196. Let's continue. So we started with 196, we osculated and came back with 196. If you start with 196 and end up with same number, after osculation, that number is divisible. So says Tirthaji. Okay, let's continue here. That means 196 is divisible by 49, and so is 1433719959. So if in doing osculation you end up with the same number as you started with, then that number is divisible. Okay, let's continue here. Okay, do some exercises now. Determine if the following numbers are divisible by 7, 14, 21, 28, 35, 42, and 49. Let's continue. First number 198948. Next number 331632. Next number 81480. Next number 1784161. Next number 2444296. Next number 1605828, and some more. Another example here. Okay. Problem is 2955303 divisible by 39. Let's continue here. The number is 299,55303. Let's continue. Multiple to use is 39. 39 times 1 is 39, and 39 does end in 9. And 1 more than 39 is 40, and proxy is 4. Okay, we're going to use 4 as a proxy. Okay, so first osculation is 3 times the proxy plus 0, 12. Okay, let's continue here. Next, now osculate again. This 12 on the right and 3 on the left. 4 times 12 plus 3 is 51. 51 is more than 39, and we reduce that to 12. Let's continue. Next osculation is 12 times the proxy 4 plus 5, 53. We reduce that to 49. 53 is more than 39 and we subtract 39 from here. Okay? Let's continue. Next we have 14 times the proxy 4 plus 5 is 61. We reduce that to 22 is take away 39. So we got 22 left next. Okay. Next is we osculate 32 and 9. 22 on the right, 9 on left. Okay, which is 4 times 22 plus 9, 97. Okay, 97. We take away 78, which is 2 times 39. 97 is too much. A lot more than 39 is, so we reduce that to become 19. Let's continue. Okay, now we osculate again 19 on right and 2 on left. 4 times 19 is 76 plus 2 is 78. Okay? And 78 is 2 times 39. So 79, 8 is divisible by 39. And so is this number 2955303. Let's continue here. 78 is divisible and so is 2955303. Do another example. Example is 150,799,73 divisible by 23. Let's continue. The number is 150,799,73. Okay. Okay, now divisible. We multiple to use 69. 69 is 23 times 3. 69 has a 9 in the end. 69 does end in 9 and one more than 69 is 70. And proxy we will use is 7. Let's continue here. Now we're going to osculate these two digits, 7 and a 3. 3 times the proxy plus the left digit. 7 times 3 plus 7, which is 28, and reduce that to 5. 28 is more than 23, and we get a 5 here. We subtract 23 from here. Okay, let's continue here. Now we're going to osculate this 5 on the right and 9 on left. So 7 times 5, 7 is the proxy here. 7 times 5 plus 9 is 44. Okay, and we will subtract 23 from here, we get a 21. 44 is more than 23, we subtract 23 from here, we get a 21. Let's continue. Okay, now we're going to osculate this 21 on the right and 9 on left. 7 is proxy, 7 times 21 plus 9 is 156. And we will reduce take away 138 from here, 23 times 6, okay, and get 18 left. Okay, let's continue. Okay, now we're going to osculate 18 on right and 7 on left, which is 7 is proxy here. 7 times 18 plus 7 is 133. Okay, now we will reduce that to get 18 here. Okay, let's continue here. All right, so now we got 18 here. We osculate that again. 18 on the right and 0 on the left. 7 times 18 plus 0 is 126. Okay, we'll reduce that to get a 11. 23 times 5 is 115. We subtract 115 from here to get a 11 here. Okay, let's continue here. Okay, now we got osculate 11 on right and 5 on left. 7 times 11 plus 5 is 82. Okay, 82, and we reduce the 69 from here. 23 times 3 we subtract from 82, get 13 left. Okay, let's continue here. So now we osculate 13 on the right and 1 on left. Proxy is 7. 7 times 13 plus 1 is 92. Okay? But 92 is divisible by 23 because 92 is 4 times 23. So 92 is divisible by 23 and so is 150,79973. Let's continue. 92 is divisible by 23 and so is 150,799. Please refer to Tirtha's book. That book has numerous examples. Okay. Okay, let's see. Do some exercises now. Are the following divisible by 13, 26, 39, 52, 65, 23, 46, 69, and 92? Let's continue here. Okay. First number 305930. Next number 930281. Next number 3427164. Next number 2472808. Next number 4821310. Next number 5852263, and some more. Now let's go do some summary here. Let's see what we did so far for osculation. Okay, let's continue. It's the most quoted VM method for divisibility. It's the only VM method mentioned in Wikipedia. Okay, let's continue. Teacher's manual does not include it, and I have not found it mentioned in Grover's books either. Okay, let's continue here. We learned one method, and one single uses the same method in her book. We have discussed that method here. I have gone over this method, gone over some steps over and over because I found that it was a little harder to learn for me. So I hope I have made it easier for you. Okay? Tirthaji book describes two methods, and Ken Williams' book Discover Vedic Math does have both those methods. Let's continue. The main reference is our teacher's manual, and it does not have that osculation method. Vedic mathematics by Bharati Tirtha Krishnaji have two methods of osculation. Vedic math for schools have the by remainders method and does not have osculation method. I didn't find it. Vedic math made easy by Bhatia doesn't have osculation either. Vedic math for all ages has one method of osculation. Okay, and here is the reference for if you wish to learn more about divisibility rule. This is the reference to go to. Okay, it has many more examples and methods mentioned.